So this is our hardware. So we have this is our NodeMCU module ESP8266 we have used. We have used Max 30102 for heart rate, and this is our temperature sensor body to detect the body temperature, and we have used DHT11 for environment temperature and humidity. So let's start our chip. I have clicked on the reset button. So now it is connecting. It is temporarily connecting to the local Wi-Fi, and on fetching the configurations it is connecting to the following IP address 192.168, and so now let's start with calculating the VPM. So I have put my finger. As you can see, it is sensing the temperature as well as the DST temperatures, the DS temperatures, and also the BPM and average BPM as well. And based on the recorded values, it is sending them to the server at /sensor/data. As the data is sent to the server, it is also updated in our front end, which can be seen every 5 seconds. It is updated every 5 seconds. Yeah, yeah. So let's move to the software part. So this is the overall system architecture of our application. Let's consisting of all the API requests that are performed to run our application. First, there is a post request on sensor/configure from our front end to store the initial configuration for our NodeMCU. As soon as the NodeMCU is started, it will fetch its configuration from the backend via proxy server from the GET request at /sensor/configure. After every 10 seconds, the sensor data is calculated, and the NodeMCU will send the data using post request at /sensor/data, and it will be stored in our database, which is the Postgres database we are using. From the front end side, every 10 seconds, we will have a get request at /sensor/data to update the sensor data to update. Yeah. And finally, we have a /sensor/history to fetch the history of all the sensor data recorded as logs in our database. So let's move to the front end. So this is our front end. In this section, on clicking the configure, a form will be opened to store the initial configuration, that is the SSID and password. This is the live data section in which the live sensor data is displayed, and every 10 seconds it gets updated. And the above is the alert if the sensor recorded values are not within the normal range. An alert will be displayed, otherwise this will show a green message. Move to the history part. We have three different charts, one for the BPM over time, the other is the body temperature over time, and third one is the room temperature and humidity over time. We also have the historical reading stored, and we can view them, and it is a paginated API, so we can have multiple pages, and we can see and find, and the data and the charts are updated accordingly based on the historical readings. There are about 10 to 15 readings displayed in each page. In the live data section, we also included an AI diagnosis, which will take the symptom of a person, let's say feeling nausea, and based on that, we can have a diagnostics from the AI. It shows that based on low heart rate and body temperature, feeling nausea may be due to hypothermia, and the room temperature is close to body temperature, and all. It shows that maybe the patient is suffering from hypothermia. Also, the backend is hosted on a railway, and this is the documentation for our backend APIs. That's all about the overall application. Thank you.